Good morning to all of you. Am I audible?
Yes, sir.
Okay, thank you. So today we would be start. Even participants are very less. So I would be wait for 1 minute maximum, and then we start. And today is the last lecture of this subject for the ongoing semester. So the last topic that we are going to learn here is multiple access techniques. Okay, now we start. So generally, in the broadcast link that is used in the LAN network consists of multiple sending and receiving nodes connected to or use a single shared link. So you can see also in the diagram, this is one of the view of the broadcast links examples where the multiple nodes are shared with the same link. And what is wired, another is wireless as shown, as well as the satellite link as well. So in the such kind of the process, we have to be required a multiple access technique. So what happens? The problem is in such type of the method, when two or more nodes transmit at the same time, their frames will collide and the link bandwidth is wasted during the collision. How to coordinate the access of multiple sending and receiving nodes to the shared link? Solution. What is the solution of this problem? To coordinate the multiple sending and receiving nodes, how to coordinate this? So we need a protocol for the coordinate of the access of the multiple nodes. So these protocols are generally called medium or multiple access control. It belongs to the sublayer of the data link layer called the MAC, medium access control. So from the multiple access protocols, what is the expectation? The main task is to minimize the collision in order to utilize the bandwidth. So how can we utilize the bandwidth? By determining when a station can use the link, what a station should do when the link is busy, and what the station should do when it involved in the collision. So that all has been be performed under this multiple access protocol. So if you have to see the taxonomy of the multiple access protocol, so you would be found it could be divided into three categories: random access protocol, control access protocol, and channelization protocol. Okay, so we are here to learn the random access protocol. We have already learned the channelization protocol in this unit. This is not in our syllabus, so we have exclude this. So we have to today learn random access protocols on which Aloha, CSMA, CSMA-CD, and some introduction of CSMA-C. Actually, in the syllabus, they have only asked about the Aloha and CSMA. They have not go for the detail of this, but we would be discuss this in detail. So in the random access or contention protocols, what is the feature of this? No station is superior to the another station, and none is assigned the control over the another. Means every station can simultaneously also send or receive the data. A station with the frame to be transmitted can use the link directly based on the procedure defined by the protocol to make the decision on whether or not to send, whether to send and whether not to send. Okay. So here for this purpose, we have to learn about the Aloha protocols. So what is the Aloha protocol? It is designed for the wireless LAN and can be used with any shared medium. Okay. So in this section, we have to be first see the pure Aloha. There are two types of Aloha. One is the pure Aloha, another is the slotted Aloha. Okay. So today we are going to learn the pure Aloha. So in the case of pure Aloha, all frames from any station are of fixed length. Whatever the frames that is coming from the any number of the station, that is having all the fixed length L bits. And the station transmit, all the stations transmit at equal transmission time. Means all the stations produce frames with equal frame length having the L bits. A station that has data can transmit at any time. After transmitting a frame, the sender waits for an acknowledgement for an amount of time that is equal to the maximum round trip propagation delay. That is mentioned here 2 into propagation time. So maximum round trip propagation delay is 2 times the propagation delay, because it is sent from the source to destination and then acknowledged from the destination to source. So this is 2 times of the propagation delay. That is the maximum amount of time for which a sender waits. If no acknowledgement was received, sender assumes that frames or acknowledgement has been destroyed, and it would be resend that frame after it waits for a random amount of time. If station failed to receive the acknowledgement after repeated transmissions, so it would be gives up. It would be try for 1 or more times, but if after the maximum limit of the retransmission would be elapsed, it would be gives up and wait for some random amount of time. Then after they would be again start the transmission. So here one important term is that is channel utilization or efficiency or throughput. So if you have to be see, throughput is the percentage of transmitted frames that arrive successfully without collisions, or the percentage of channel bandwidth that will be used for transmitting frames without collisions. This is called as the channel utilization or efficiency or the throughput. Aloha maximum channel utilization is 18%. Means if the system produces f frames per second, 0.18 into f frames will be arrived successfully on an average without need of retransmission. Means out of, suppose they have sent 100 frames, so out of 100 frames, 18 frames would be successfully reached to the destination without any need of retransmission. This is the throughput of the Aloha technique, pure Aloha technique. So now we have to define the maximum propagation delay, that we have used the term as before. So what is the maximum propagation time? The time it takes for a bit of a frame to travel between the 2 most widely separated stations. So from this diagram we can see here, station A begins transmission at time is equal to t0, and this frame would be, bit of frame would be start to travel, and whatever the maximum farthest station is, that is station B is here. So when the amount of time need to reach to this farthest station of the first bit of the frame, it is called the propagation delay. So you can see that at t is equal to t propagation, this frame bit of the first bit of the frame has been reached to the station B, and the distance would be is d meters. So t propagation is distance upon velocity of this or speed of the transmission. Now we have to be see one procedure that would be derive you the procedure for the pure Aloha. Okay, so if you have to be see the procedure for the pure Aloha, we have to be start. Station has start a frame. Please take the screenshot of this procedure. To send, K is equal here number of attempts. So initially the number of attempts is 0, and then the first frame would be start to send from the station. So send the frame, and sender would be wait for the time, that is 2 into propagation delay. So that is, it would be wait for the acknowledgement signal. If acknowledgement received means transmission is successful, it would be stopped. But if acknowledgement is not received after 2 into TP, then what happens? It would be again go for the next attempt, K plus 1, means 0 plus 1 is 1. Or if the first attempt is already done, so second attempt. So this way, attempts would be advanced by 1, and it would be try till the K is not greater than K max. So what is the K max for the pure Aloha? It is normally 15 attempts. After 15 attempts, if still the acknowledgement is not received, so it would be about the procedure of the transmission. If before the 50 attempts it would be received, so it would be go for the, if K is not greater than the K max, then it would be choose a random number R between the 0 to 2 raised to power K minus 1, and then again it would be wait for the time, backup time, that is TB, that is R into TP or R into TFR. TFR is average transmission time for a frame, and then again resend the frames till it would be not achieve the maximum attempts. Okay, so this is the way that how the pure Aloha works. Now one more important parameter is the critical time or vulnerable time for the pure Aloha. So if we have to be seen the diagram, at the time T minus T frame, after some amount of time this between this T minus T frame and T, B station would be start to begin its frame, but before the end of this frame duration, another station A would be start to send. So what happens in this position at the time T, B end is collides with the A's beginning. Similarly for the A and C, so there will be the wastage of the data and wastage of time also. So what does critical time means is that if the frame transmission time is T frame per second, T frame second, then vulnerable time is 2 into T frame. Means critical time is here what? No station should send during the T frame second before this station start transmission, and no station should start the transmission during the T frame second that current station is sending. Otherwise collision would be occur. So you have to be wait for the 2 into T frame second, then and then only after that another station would be start to sending the data. Okay, so this is also very important characteristics of the Aloha, and this is the diagram that's showing that how the Aloha has been performed actually. So in this case, if you have to be see, station 1 is sending the frames at regular interval of time, then station 2 would be also sending, and station 3. But when we have to be observed in the channel, so in the broadcast channel, till the second frame there is no collision, but here when station 1 and station 3 frames are sended at the same time, collision occurs, means that there is a wastage of frame and wastage of the time also. Similarly here there is a partial collision is there, it would be again responsible for the wastage of the frame. So in the pure Aloha actually frames are transmitted at completely arbitrary times. There is no control over that when you have to be sent, and that's why the collision would be occurs. So how to overcome from this kind of the problems, we have to be see in the next section. there is a another aspect of the Aloha, pure Aloha, is that we have to be calculate. That is throughput of this pure Aloha, or the efficiency of this pure Aloha. The S is equal to G into e raised to power minus 2G. And the maximum throughput of pure Aloha is S max 0.184. And it would be only possible when G is equal to 1 by 2. So what is G here? G is average number of frames generated by the system during one frame transmission time. Average number of frames generated by the all stations during one frame transmission time. So when the G is half, then S or throughput is maximum, because the critical time is 2 into T frame. So this means that 18.4% of the frames would be successfully reached to the destination without any collision. So whatever the problem we have faced of the collision in the pure Aloha, that would be little bit overcome with the help of the another method, that is called the slotted Aloha. So time is here divided into the slots equal to the frame transmission time. A station can transmit at the beginning of the slot only, not like the pure Aloha at any time. It had to only send during the beginning of the slot only. If the station misses, the beginning of the slot, it has to be wait until the beginning of the next time slot is not came. A central clock or station informs all stations about the start of each slot, and the maximum utilization is here 37%. So now you have to see that utilization has been increased from the 18.4 to the 37% because of this technique. So you have to see the overview of this slotted Aloha. Still there is a chances of the collision, but it would be less as compared to the pure Aloha. You can see here, as we have said that you have to be only sent at the beginning of the time slot. So here the station B has started at the beginning of time slot, but when it would be end, at that time the another station A and C has missed out that beginning of time slot. So both has to be wait for the next time slot. But what happens, as the two station has missed this time slot, so A and C would be start to at the same time, and because of that there is a collision occurs. But here you can see that this vulnerable or critical time is only T frame. It is less. That's why the efficiency is improves. So this is the actual graph. You can see that, or the picture, that how the collision would be occur in the slotted Aloha. But the chances of collision would be become half as compared to the pure Aloha. And the throughput of the slotted Aloha is S is equal to G into e to raised to the power minus G. In the previous case, it is e raised to the power minus 2G. So formula is very important, and you have to be take care of the differences between the formula. And here S max is 0.368, means 36.8% when G is equal to 1, because here vulnerable time is T frame only. Okay. Now again, we have not able to solve or resolve completely the problem of the collision. This is the graph that is showing the efficiency of the Aloha technique for pure Aloha and slotted Aloha. So it is the y-axis, we have to show the throughput or success rate, and the x-axis we have to show the G, means offer load rate. Okay, total number of frames that is presented to the link per transmission time of a single frame. So you have to see that from the graph it is very much clear. The efficiency of the slotted Aloha is double nearly with respect to the pure Aloha. So what is the advantage of Aloha is here? A node that frames to be transmitted can transmit continuously at the full rate of channel if it is only node with the frames. It is simple to implement. no master station to control this system. Okay. But there is also a disadvantage that if m nodes want to transmit, so there is a many collisions can occur, and the rate allocated for each node will be not be on average r upon m bits per second, and this would be responsible for low channel utilization. Now, to overcome this problem, we have to go for another random access technique, that is called the CSM, carrier sense multiple access. Okay, so carrier sense multiple access means it would be used to improve the performance, avoid the transmission that are certain to cause the collision, and based on the fact that in the LAN propagation time is very small, if a frame was sent by a station, all station knows immediately so that they can wait before start the sending the frames. A station with the frames to be sent should send the medium first for the presence of another transmission before it starts its own transmission, and this can reduce the possibility of the collision. But again, remember that it can't eliminate completely the problem of collision. So CSMA is based on the principle sense before transmit or listen before talk. So this is the structure. If you have to be see, that is shown for the CSMA technique. So here you can see that collision only happens when more than one station begin transmitting within the short time. So what happens? Here the device A or station A, B, and up to the Z station has been shown. So A would be start to transmission at the T1 second, and it would be take some time. This frame would be take some time to reach to the station Z. So what happens? Station would be found that during that amount of time when the frame would be reached to it, it would be found that channel is idle. There is no transmission is occurring. So what happens? Z would be also start to transmit. Okay, at time T2 after the some amount of time of T1. But what happens? Both the station in between somewhere it would be start and it would be collide it with each other. And when the collision occurs, the acknowledgement of collision would be reached to the Z at the T4 time and at the A T5 time. And at the time T3, the collision has occurred. So this is also the chances of collision in this technique. The same has been shown with the help of this graph. That is, this graph would be show you the critical time or vulnerable time for the carrier sense multiple access technique. So show vulnerable time for CSMA is maximum propagation time it is required. So the longer the propagation delay, the worse the performance of the protocol because of the chances of the collision would be increased. Okay, so here you can see that the multiple stations are there, A, B, C, D. So at the time A start to sending its frame, and B would be sends after some amount of time, C would be send more amount of delay, and D would be sends maximum delay. So this amount of delay, that when the A sends the frames and it would be reach a time to up to the station D, it is called the maximum propagation time or vulnerable time is here. So generally there are three types of the CSMA protocols: non-persistence, one-persistent, and p-persistent. First of all, we have to see the non-persistent CSMA. Here you can see from the diagram also it is very much clear. A station with the frames to be sent should sense the medium first. So there's a two way it would be sensed. First, it would be found if medium is idle, then it would be start the transmission. Otherwise, go to the second step. So what is this? If medium is busy, so it would be wait for a random amount of time and then again repeat the one. So if you have to be see here, So non-persistent stations are differential, and if you have to talk about the performance of this, the random delay reduces the probability of the collisions because two stations with the data to be transmitted will wait for different amount of times. So you can see here, if channel is busy, it would be wait for this, continuously it would be sensing the channel, and when it would be found it is idle, then it will be start to transmit in this particular point. But what happens during this sensing? Sometimes it would be sensing continuously and found the channel is busy. So it would be also wait for some random amount of time. So during that, there is a so in the diagram there is a wastage of the time, because here there is channel is idle, but it is not sensed by this station, and because of this, the time would be wastage. This is the non-persistent technique. So here the bandwidth is wasted if waiting time is large, because medium would be remains idle following end of the transmission, even if one or more station have frames to send. So we have to go for the next one, that is one persistent CSMA. To avoid the idle channel time, one persistent protocol is used. Here you can see that station wishing to transmit, so listen the medium continuously sensing, not the randomly. Okay. So if medium is idle, transmit immediately. So here we have to save the wastage time. But if the medium is busy, so continuously listen until the medium become idle, and then transmit immediately with the probability of 1. That's why it is called the one persistent. One persistent stations are basically selfish. If two or more stations become ready at the same time, then there is a guarantee of the collision. Again, there is a one problem of collision is not removed, but even the performance is improved as compared to the non-persistent. The third technique is P-persistent. So time is divided into the slots, where each time slot unit typically equals the maximum propagation delay. A station wishing to transmit listens to medium. If medium is here, again the continuously sensing is done, but the time slot is allocated here. But the medium is idle, transmit the probability of the P, or wait one time unit or one time slot with probability of 1 minus P, and then again transmit. But if the medium is busy, so continuously listen until the idle state is not reached, and then again repeat the step 1. So if you have to talk about the performance of P persistent, it would be reduce the possibility of the collision like non-persistent, and it would be reduce the channel idle time like one persistent. That is superior to all of these three methods. It would be overcome the problem with the non-persistent, as well as it has the same benefits as we have to be got in the one persistent CSMA technique. The same three technique has been shown here with the help of this diagram. So either you can follow these three diagrams, or you have to use this diagram to define the non-persistent, one persistent, and P persistent technique. Okay. So you can take the screenshot of this. It's the same that I have taught you. Now you have to see the performance of persistent, non-persistent CSMA along with the Aloha. That is shown through this graph. You can also take the screenshot of this. It is very easily understood with the help of this is a graph between the throughput versus attempts per packet time, that is G. So now we have to move to the CSMA technique with collision detection, CSMA CD. So CSMA, whatever the all previous methods we have seen, that has an inefficiency. What is the inefficiency within that? If the collision has occurred, channel is unstable until colliding packets has been fully transmitted. So CSMA CD overcomes this problem. Carrier sends multiple SS with the collision detection. While transmission would be, the sender is listening to the medium for the collisions, and sender stops transmission if collision has occurred. And in this way, it would be reduce the channel wastage. CSMA CD is widely used for the bus topology lines like IEEE 802.3 or Ethernet. These are the applications where we have to use the CSMA CD techniques. So how does a node detect a collision? We know that. So a node monitors the media while transmitting. If the observed power is more than the transmitted power of its own signal, it means the collision occurred. So during the collision, what happens? Power would be doubled. That is basically happens with the hub. When the hub would be indicate the collisions and send the collision presence signals on all ports. So in the CSMA CD protocol, it would be follow the persistent algorithm for transmission. If collision is detected by a station during a transmission, then it should do the following. First, it would be abort the transmission, then transmit a jam signal that is having of the 48-bit signal to notify other stations of the collision so that they will be discard the transmission frame. Also, to make sure that the collision signal will be stay until detected by the farthest station. After sending the jam signal, it would be wait for the backup time, that is a random amount of time, and then again transmit the frames. So this is shown how long does it take to detect a collision. In the worst case, CSMA CD technique would be take the twice the maximum propagation delay of the medium. Here you can see that A has started to begin the transmission. After T0 plus A minus X time, B would be start to begin when the frame of A is very near to the station B. At a T0 plus A time, what happens? The collision would be B detects the collision. And after T0 plus 2A time, A detects the collision because A would be not know immediately. It would take some time because the frame has propagated for a long amount of distance. So A is here maximum propagation delay. So how many the maximum time it would take? Twice of A. Okay. Please maintain silence. Okay. Now you have to be found that this is the graph that is showing the collision of the first bit in CSMA CD. So you have to be see that there is some stations A, B, C, and D are there, and at the time T1, first bit of A has been be transmitted. After some amount of time, at the T2, C would be also start to transmit on the both direction. And that time T3, you have to find that collision would be occurred. So if you have to be see here. So if you have to be found that here, so you would be find that the collision would be occurred. Okay, so you have to be found that this collision would be occur at the time T3 and D would be C would be when the collision occurs, it would be detect and abort the transmission. Okay, but A would be detect this collision after very long amount of time, that is at the T4. Okay, so in this way, if you have to be found that this problem would be occurred in the CSMA CD also when the collision day, but it would be immediately about the transmission. That would be shown with the help of this graph in more detail. Okay, so you can take the screenshot of this. That would be diagram is very much simple to understand that how the collision occurs and how to avoid the transmission and when it will transmit the next frames. Now, what are the restrictions with the CSMA CD? So the packet transmission time should be at least as long as the time needed to detect the collision. So it is twice of maximum propagation delay plus jam sequence time. Otherwise, CSMA CD does not have an advantage over the CSMA. Okay. So this is the flow diagram for the CSMA CD. That would be very simple to learn. That it would be start, the number of attempts would be 0 initially, then the first attempt would be done, and apply one of the persistent method, either the one persistent, non-persistent, or the P persistent, and it would be eligible for the transmission done, and the collision, if the collision detected, then there would be, if it would be the transmission done and no collision, is a successful transmission. But if the collision detected, it would be go for the retransmission. And if the collision would be detected, then first of all it would be send the jamming signal to avoid this transmission and go for the next attempt until it would not achieve the maximum attempts, that is Kmax. If after achieving the maximum attempt the transmission is not successful, so it would be avoid the transmission. But if it is in between of that K value between 0 to 2k raised to power k minus 1, it would be resending the transmission after the wait time of the TV, that is backup time. Okay, so this is the energy level transmission during the transmission, that you have to see that there is a 3-state, 0, normal, and there is an abnormal. So when the collision occurs, there is abnormally the energy level would be increased. Okay, that is shown here. There is another technique that is called the CSMA CA, when the collision avoidance technique, where we have to be wait for the interframe space time, and then again as a contention window would be used for the retransmission. So in this time slot, it would be sending the frames again. So in the CSMA CA, interframe space can be also used for define the priority of the station or a frame to resending the data. Okay, so basically in the CSMA CA, that is the carrier sense multiple essence collision avoidance, if the station finds the channel busy, it does not restart the timer of the contention window. It stops the timer and restart it when the channel becomes again idle. So this is the flow graph for the CSMA CA. Please take the screenshot and start to fill up the attendance simultaneously. So it would be find that if the channel is idle, then it would be transmit, wait for the interframe space time, but still it is idle, it would be found, then it would be start to send the data. If it is not idle, then it would be again go back to the same condition and again wait for the channel would be become idle. Okay, and then it would be, if we found the idle, it would be send the data, wait R slots, after each slot it would be idle, if idle continue, if busy halt for that amount of time and send the frame, and when it will be received the acknowledgement, the transmission is successful. Again go for the K next attempt and next attempt, and we'll go for the maximum attempt of time. So these are the references for this topics, the 6th unit. So thank you all of you for attending lecture, and hope you would do well for your prelim examination and the university examination. Thank you all of you. Please fill the attendance fast, very less amount of time is remaining.